All right. The quadratic formula, some people really like it, some people don't like it so much. But the big thing with the quadratic formula is it works all the time. So factoring, when you solve by factoring, that's kind of nice when they actually factor. But either some of them don't factor or some of them are pretty difficult to factor if you have bigger numbers and negatives and different stuff like that. The quadratic formula works for all of them. So that's kind of the upside to the quadratic formula. And the thing I like about the quadratic formula is I don't make you memorize it. So as long as you know how to plug numbers in and you can put them in your calculator, really, I don't think it's as hard as a lot of people think it is. You do have to be meticulous and make sure you're plugging things in where they need to be. So first off, not that I actually am too finicky with this, but there's a difference between a quadratic equation and the quadratic formula. A quadratic equation is what we've been looking at, where we have the ax squared plus bx plus c. The quadratic formula is what we use to solve that. Now, again, I'm not going to be finicky with this. I call the quadratic formula the quadratic equation a lot. Not a huge deal. But overall, that I did want to point that out, that we use the quadratic formula when we're solving those equations. Also, I should point out, before I forget, I changed this. I want you to use decimals as your answers. So don't look at that. And again, I am very contradictory because later I tell you, basically, I forgot that I put that there. Okay, so the quadratic formula, again, you will have this on your test. I will not make you memorize that. And maybe that's force you to memorize it earlier. I'm not going to do that. Every test that I've ever seen, they give you that at this level. So I will give you that. Some important things I want to talk about. First off, you need to show me the first step when you plug your numbers in. After that, every step that I show you is very strongly recommended, but it's not necessary. But I do need to see that you plug things into that first step. There are too many things out there. I know some of the new calculators you buy, they have a quadratic formula solver where all you have to do is put the three numbers in and hit a button, and it does it for you. That's great, super handy, but I need to make sure you know how to plug numbers in. So once you plug them in, then you can use that and get the answer. That's fine. But I need to make sure you can plug numbers in. And again, I'll show you kind of the steps that I take to do that. Just like solving with factoring, you need to set these equal to 0. So if you have anything on both sides of the equation, you need to put it all on one side so it's equal to 0. The 2 and the 4, so everything that's printed out in black, I know yours isn't in color, but everything that I have in black always stays there. Nothing changed with that. The ones that are in different colors, those are the numbers that change. So the punchline is, every time I do this, I have somebody that asks, well, where do you get the 4 from? Well, the 4 is in your calculator. If you genuinely wonder why, the 4 is in the formula. If you genuinely wonder why that 4 is there, you can come talk to me later, and I'll talk about how they found the quadratic being the square, and we'll all be better people for it. I am willing to bet no one's going to do that, but that's okay. Follow the order of operations, but honestly, use a calculator and use parentheses. Again, I'm going to show you where I type most of the hard stuff. I just type in my calculator. And again, I didn't used to do that, but I had a lot of people that got confused with, are we that -4? Is that a -4? Are we subtracting 4? What's that going to look like? Do we put it in? And like a lot of people got confused at the order of operations and positives and negatives. So if you just put in your calculator, we can alleviate all that. Make sure you double check, make sure you plugged everything in correctly. Again, without fail, some people plug everything in. They try to do everything they're supposed to. They just missed one little thing. They write down a plus instead of a minus, or they forget to square the b, or something like that. And then lastly, this is what I was talking about, where I said put your answer as decimals, and then I changed my mind. But don't put your answers as decimals. I want you to leave them with the square root in them for some of them, and we'll talk about that in a second. That's going to help us later on. I think you did a little bit in Algebra 1, but we do goals, and we'll do the next chapter. And so I think this kind of helps you see what those look like, comfortable with that notation before we get into that reducing problem. Okay, so let's do our first quadratic equation. So the first thing I do is I list. Now, again, this part you don't actually have to do, but I do think it's very advantageous to do this, especially with positives and negatives. Now, notice my A, B, and C are the same. A, B, and C we've always done. A, B, C. There are no X's in there. That's a common mistake that some people do. They plug everything into their quadratic formula, and then they try to ask me why they can't figure it out, and it's because for A, they put down 2x squared. No, the A, B, and C are just numbers. You won't have any variables in there. This is where you plug into your equation. So I have x is equal to, now every time I ever plug in numbers, I always use parentheses. I know I've talked about this before, but sometimes you don't need to do that. But it seems like if you try to pick and choose when you do and don't need it, you end up making a little mistake. So I just always use parentheses. It's negative b, which is plus or minus the square root of b squared, so 11 squared, minus a times c is 12 over 2 times a. That is the step I need to see. Again, not rocket surgery. All I do is I plug in every time I see your formula. Every time I see an A, I put a 2. Every time an 11, and every time I see I put a 12. Normal substitution. I do need to see that step. If after this, if you want to put that in your calculator now, you can. But you can't. So, with the calculators, with the new calculators, and some of them you have, I don't know what some of the Texas Instruments do, but a lot of calculators, you can type in a fraction, you can type in a square root, and you can make it look really nice. And so I have students that sometimes, once they get here, they type that whole thing in their calculator, and they hit enter, and they write down their answer. If you want to do that, that's up to you. My only problem with that is there's a lot of stuff to type in. The more stuff you type in your calculator, the more often you accidentally forget the square, or you accidentally don't put 12, you put in a 2 or something. And if you make a little tiny mistake when you put it in your calculator, it's gonna give you the wrong answer. Now again, if you have this correct but the wrong answer, you'll still get a point, so not a huge deal. But the more steps you can show me, the more chance I have to give you partial credit. So this is what I actually, before I start that last thing, I forgot. Make sure to remember minus sign is also not in your calculator. Remember, this is writing 2 equations all in one spot. Negative 11 plus the square root of all this over 2 times 2, and negative 11 minus the square root of blah, blah, blah over 2 times 2. If you type in your calculator, you'll need to type in negative 11 plus the square root of 11 squared minus 4 times 2 times 12 over 2 times 2. And then 11 minus square root of 11 squared minus 4 times 2 times 12 over 2 times 2. I had people literally during a test, I'll come up and say, where's the plus and minus sign in my calculator? And there are 2 separate lines. This is one. Put that in my calculator. Some of you guys, it usually is people who are pretty good with computers. They type that on their calculator. Again, if you want to, that's up to you. But you're running the risk where if you miss a little bit, I'm going to have to count a point off. So what is my next step, I call it cleaning up, because I just make it look not as terrible as that. So what I do is, my negative 11, I just write as negative 11. My 2 times 2 here, I write as 4, and then my square root, I just put in my calculator. Now this is what I was talking about, where a lot of people get confused. Am I subtracting 4, or is it negative 4, or how do you don't have to worry about it. Just put it in your calculator. Just make sure you calculator exactly how you see it with the parentheses. So when I type it in my calculator, I type in parenthesis 11 parenthesis squared minus 4 parenthesis 2 parenthesis 12 parenthesis. And I know that's a little bit of overkill, and there's a couple shortcuts you can take. But again, at a certain point, if I tell you where they're shortcuts, I think some people are going to mess things up. So just type it in exactly how you see it with parentheses. Now, again, at any point, if you want to bail and do it in your calculator, that's up to you. But every step you can show me, again, is more places I can give you partial credit. and it's the less amount that you have to type in your calculator, the less chance you have of making a small mistake somewhere. So I keep simplifying. I simplify my square roots. Let x plus or minus is 5. If you need to. This is where, and I equations, but there's two different outcomes here. We have negative plus 5 over 4, and we have negative 11 minus 5 over 4. Those are your two outcomes. Again, at this point, if you just want to type that in your calculator, you don't want to, you just want to type in negative plus 5 over 4 and negative 11 minus 5 over 4. Again, I don't care what type of work you show. Plus 5, 8, no, 6. Joke because I was on the thing. Should probably delete this recording now. You end up getting negative 6 over 4, which reduces to negative 3 over 2. 11 minus 5 is negative 16 divided by 4. Negative 16 divided by 4 is negative 4. So, I don't know if I mentioned it yesterday, but for the most part, we get 2 answers for all these. We'll talk about that in a little bit more depth later. You get 2 answers, or if you get 1 answer, it's 2 answers better than or you get 2 answers later. And again, your calculator should do that for you. But again, the more steps you show me, the more I can give you a point and different stuff like that. But I assure you, that first step I did in blue, if you don't show me that and you have the right answers, I'm going to count you wrong. Again, there's too much places where you can type it in quickly, and I need to know that you can plug stuff in. Bell's going to ring it for lunch in a second. When we get back, we'll finish this up. All right, go ahead. If you haven't done it already, go ahead and start with the, sorry, not number 3. Number 2, do that one on your own. It's obviously fairly similar to number 1. I'll put the answer up here in a second, and then we'll move on. That's not what I wanted. All right, so my answer's up there. Again, make sure you add 4 to both sides. You have to get 0 on one side to solve. Personally, I always make whatever makes your x squared term positive. That's where I put everything. You don't really need to know that, or I don't think it matters too much. But my A is 5, my B is 9, my C is 4. Again, this first in green here, you need that step. Even if you just show me, even if you go straight from there to your answer, that's fine if you put it in your calculator, but I need to see that step where you plugged everything in. I think that's also going to help if you put it in your calculator. I think that's also going to help you make sure you don't forget anything. I ended up getting the square root of 1. If you did the longer way like I do it, the square root of 1 is just 1. Again, if you didn't know that, use your calculator. So negative 9 plus 1 over 10, negative 9 minus 1 over 10. That ends up giving you negative 4 over 5 and negative 1. Any questions on that one before we move on? So the next one that we're looking at starts out the same way as before. So we add 10 to both sides. 2x squared minus 7x minus 3 is equal to 0. Negative 13 plus 10. Make sure when you do that, you are adding like terms. I had some people that in this last one, they added the 9x and they added the 4 to the 9x. Remember, you can only add x squares to x squareds, x's to x's, and constants to constants. You have to make sure you combine like terms. So now you can list out your A is 2, your B is negative 7, your C is negative 3. Make sure you're careful with your negatives. Just like before, we're going to plug those in. So x is equal to negative B is negative 7. Plus or minus the square root of negative 7 squared minus 4 times A times C. all over 2 times 10. Actually, when I tell you to make sure you use parentheses, this one especially, if you don't use parentheses and you just type in -7 squared, that's the big spot. That's the spot that will not give you the right answer. So again, just every time you plug a number in, use parentheses, and if you're going to type in your calculator, I would type it out exactly how you see it. Again, if you go straight from that to your answer, that's for me though, I'm going to put this extra where I clean everything. I get 7 over 4. Inside the square root, I have -4. It's 70. Now this is where some of you guys will like this better, and some of you guys will get confused a little bit by this until we get some more practice. That's why I said I thought about making you put it in the decimal, but instead I leave it that way so you can kind of get used to the looks where you have square root, which just FYI is also called a radical. Ever refer to it as that. Having that in your answer. So if you type this in your calculator, at least in those calculators, it should spit that as an answer. I mean, obviously it's going to have to do in 2 separate sections, 7 plus square root of 73 over 4 and 7 minus square root of 73 over 4. But your calculator, a calculator that doesn't do that, if you want to come and ask me, or if you want to YouTube or Google anything, I know there's different settings for different ones. I just had one of the calculators that wasn't doing that as an answer. So if that's you, we can try to figure it out. But I'm okay with you doing that and leaving that answer. Now, if you ever wonder, how do we know when to simplify it and when to leave it like that? The answer is if you can simplify it. So this one, the square root of 25, that shows up. The square root of 25 is just 5. And the one we did, number 2, the square root of 1 is just 1. But this one, the square root of 73, honestly, in most of your calculators, if you type that in, 73. If you want to find it as a decimal, it gives you a real long decimal, that's fine. But that square root is not a nice whole number. And so that's why we leave it like that. So I personally, I would like those better because it's done already. There's not a lot of extra work you can do for that. I don't think we'll have time to do number 5, but go ahead and do number 4 on your own. And then we'll go into types of problems we'll get to. All right, not to rush you, but my answer's up there. And again, figure out when do we leave this at that and when do we actually solve it where we get like fraction as our answer. The difference is if it's possible. This one, you cannot, the square root of 305 is a weird decimal, so you can't get that down to a fraction. It's going to be, I mean, you can't do it that way or it's going to be more difficult. So wondering that square root of 305 in your calculator and see what comes up. If it comes up as a whole number, then put that whole number. If it comes up as the square root of 305, then just leave it like that. Later on in our next chapter, talk about how to reduce radicals, and I think you did that back in Algebra 1, which has probably been a while. You probably hated doing it then, and probably. I decided rather than for this and making this more complicated, I'm just going to stick to some of these basics, and then we'll work on the reducing radicals. That way, kind of keep it separate. We don't have to worry about it yet. Are there any questions so far? Of answers you'll get? You'll either get answers where you get like fractions and whole numbers, like we did with number 1 and 2, or you'll get the answers where you have a square root inside of your answer. Again, it all depends on if it can reduce or not. Okay, now really quickly, this is not going to be on our test. We will get into this later, so get ready to live. But I want to talk really quickly about because the next thing we're going to do. How do we know without how do we know if we're going to get real answers or imaginary answers? We haven't really talked about imaginary. That's something you don't do in Algebra 1. So just very quickly, what's an imaginary number? we can never take the square root of a negative number. If you try putting the square root of a calculator, it'll probably come to 0. And I kind of put, because we can't take the square root, it has to be whatever. I talk about that there. So one of the things they did so we can actually work with these numbers is they call them imaginary numbers. And the basics of it is that the square root of -1 is equal to the imaginary number that's just represented by I. So I is equal to the square root of -1. We will get into that a lot, and we'll do a lot of different things with that. But first, we're going to look at just the basics. If I have the square root of -144, that is, the square root of 144 is 12. So since it's negative, it's 12i. That's it. Obviously, numbers get a lot more complex than that, but for right now, that's all it is. The square is 3. The square root of 3. What about 7, though? The square root of 7, that's when you're decimal. And so I leave it as the square root of 7, and I put the I in front. Now, technically, you can put the I in back. Not inside your square root. But normal notation, we usually put that in front. Now, again, I'm not going to get into doing problems like this. I thought about this when I was at Goshen, we did, but literally all it was adding that I in there, and I didn't think it was very advantageous. So, with in mind, I just showed you if you were to have that quadratic formula, or that quadratic equation, formula, you'd end up with 4 over 10. You just move that I in front, so it would be 4 plus or minus I times the square root of 104 over 10. That's not going to be on a test, so if that so far right now is really confusing, don't even worry about it. We'll get into a lot more details with that later. Now, the only reason, because you're maybe asking yourself, so if that's not on a test, why go over it? Well, the reason is because back in Algebra 1, and I could be wrong, we talked about the discriminant, and we talked about you can tell if you have 2 real solutions, 1 real solution, or no solutions. Well, now, in Algebra 2, we go one step further. There's not no solutions. Instead of no solutions, there's actually 2 imaginary solutions. And so we're just going one more step from Algebra 1. To find out how many solutions there are and what kind of solutions there are, we use something called the discriminant. And the discriminant, the formula is right here, and it's the exact same formula as whatever's inside the square root of your quadratic formula. You will get that on a test. I thought about not giving it to you because, again, I'd like you to know that it's the inside of that radical, the square root of the quadratic formula. But I'm going to go ahead and give that to you on a test and on the final exam. But if you plug, it tells you how many solutions you have and what type. Now, we don't care what the numbers are when we plug our numbers in. All we care about is when we plug numbers in, are we going to get a positive number, a negative number, or 0? And it makes sense if you think about it, because if you're doing a formula, so you have 10 plus or minus, the square root is a positive number. Well, the square root is fine, we'll end up getting 2 answers, just like normal. Well, what if the square root is a negative number? Well, if the square root is a negative number, now we're going to get 2 imaginary, because you can't take the square root of a negative. 0, it's going to end up giving you 1 solution. So the shortcut is, rather than doing the whole quadratic formula, if we can just look at what answer we get inside of our radical, if that's positive, negative, or 0, we can tell this. We can tell which one it goes with. Now, again, not to be that guy, but if that didn't make any sense and why it is and why we have the quadratic formula, how that all works together, honestly, you don't really need to know it, as long as you know what the formula is. What answer that formula gives you. Now, again, I put this up here, and I'll probably say it a couple more times, but I'll tell you what answer you're getting. So that the answer is that is discriminant. We positive, negative, or 0, and that's going to tell us which one it goes with. So, for instance, if we look at the same A, B, and C as before, so we have 1, 5, and 2. If we plug that into the discriminant, we have 5 squared minus 4 times 1 times 2. Just put that in your calculator. Put that in your calculator just like we did before. positive 17. Again, please put 17 because I'm looking for that to at least give you partial credit and at least help you. Greater than 17, I care that it's a positive number. Because that means we have two real. Now, I'll tell you again, I'll give you that formula on the test, but I'm going to give you that what it means. I'm not going to give you that two positive answers, two real, a negative answer is two imaginary, and a 0 is one real. I'm not going to give you that part. You should be able to remember three things if you take the time. Other thing is, if you don't remember that, you could also use the quadratic formula and look at your answer. Did the quadratic formula give you two answers? Did the quadratic formula end up with a square root of a negative, so you have imaginary? Or did the quadratic formula end up giving you one answer? So you could do it. Takes a little bit longer, but wouldn't be the realm of possibility. So let's do the next. Just like before, so 9x squared plus 6x plus 1 is equal to 0. So my A is 9, B is 6, C is 1. So again, 6 minus 4 times 9 times 1. If you put that, gives you 0. Well, again, 0 means you get one real solution. And last but not least, same thing with this one. If you add 10 to both sides, you end up with 9x squared minus 3x plus 2. So my A is 9, B is negative 3, C is 2. So that is negative 3 squared minus 4 times 9 times 2. Again, if you put that in your calculator, you get negative 63, which again, that's really handy, and I will be looking for that, but the important thing is it's negative. And if you get a negative answer, you get two imaginary numbers. That's the extent of imaginary numbers on your test and on your quiz and on the final is going to be that. If you have imaginary numbers next semester, that's the only thing you'll have with imaginary is doing the discriminants and realizing that a negative gives you two imaginary. Now, the last thing I will say with this, is that those are your only three options. One real number or two imaginary numbers. You will never have one that gives you one imaginary. That's impossible. We're not going to go into the depths this year, but one of the things high level math is that numbers come in pairs, 2, 4, 6, 8, 10, so on and so forth. You'll never have an odd number. That doesn't matter. You'll have one imaginary number. For these purposes, you'll never have you'll never have three real solutions. It's not going to happen. These are quadratics. So those are your only three options. Options you can take right away because those are the only either two real. All right, make sure you're ready. Again, this is one of those things that does help with some practice. If you have any questions, let me know. And again, our